Hello and welcome to the last and final part of this tutorial series about OpenTTD. I am Damage and I'll be explaining a few things about junctions and networks and the advanced ins and outs of them. So, networks. Let's take a look at those. So here we have the network that I have currently in this game. Now, what a network is for, in my eyes, is just for transporting the goods at a high efficiency while using the minimal amount of tracks. You could just hook up a station to a station with just a straight connection with only one train going on it. In terms of efficiency and transportation speed, if you just build a straight line, then that is more efficient and you can transport at higher speed. However, if you then want to run 10 trains over there, you are in a bit of a problem because you then need 10 train lines, and if you then want to hook up another 5 iron ore mines to a steel mill, for example, all of a sudden you end up with 50 train lines, and you can quickly see why that's not the most effective way to gain massive profits. So that's why networks, in my eyes, are the way to play this game. Now what you see over here is a part of the network that I have, and the network really it has two basic station types in there. You got supplying stations like iron ore mines and forests and stuff, and you got receiving stations which process those materials. The way I usually set up a network is that I have lots of supplying stations but only a few really big receiving stations. Now there are two advantages to that because, well, one, I get to build really big and advanced and high efficiency stations at those factories and steel mills, and two, it keeps your network nice and tidy because there isn't a lot of multi-directional traffic on your network. In general, the trains only got a few destinations really, which is the supplying station and only a handful of choices of receiving stations. You could also hook up a lot of receiving stations to your network, but that would generate a lot of multi-directional traffic and you'd have a lot of big junctions in your network. And well, right now I only got a few big junctions, and let's just take a more in-depth look at this network. So I just explained about the station types in the network, but the network itself really consists of main track lines, which are these, and then you got like branches coming off of those main track lines, which are those. Now when you start up a network, really, you got your first main track line and a few branches off, but later on you might want to tag along more resource nodes, and well, generally speaking, you got your main track line. You don't want to have everything hook up to the main track line. You want to keep it a bit organized. Like, for example, you can see over here that we got 3 resource nodes, and instead of having all 3 of them hook up to the main track line, I combined them into one line hooking up over here. The thing is with these main track lines is that each and every junction really reduces its efficiency by a tiny bit. Now obviously you can't go without junctions, so it's not like they're always bad, but if you have an unnecessary amount of junctions, then yeah, it does drop the efficiency down a bit. So, well, how you set up a network? Generally, because the way I play with only a few receiving stations, and those tend to be quite big, you want to be really picky about the location of your first receiving station. What I usually do is I choose a receiving station, like for example a steel mill, at the edge of the map, and then just have that be the end of the line. So you can see that, for example, over here where I got this very small backup network, and we have a power station over here which is really at the edge of the map. Now we got the first main track line over here, which really is also the end of the line really. There's no junction or anything. Now later on I built the second main line over here, and you can see that we needed to make a junction and we could hook up more coal mines. And this is really just how the start of a network usually goes, and then later on you can expand it with like another main track line and then hook up even more resource nodes, get another receiving station. But in general that's my preferred way of setting it up, as it's quite easy and cost efficient. Now when planning out your first receiving station, you also want to keep one thing in mind in regards to the main lines. And that is that as you can see right now in this section of the network, it's easily to spot where the junctions are. We got one over here and the others are over here. Those junctions in the main track line are generally really big because they got a lot of traffic going to lots of directions. So you want to plan out those junctions just as carefully as you do your receiving stations, as they both take up a lot of space. So that's a thing to keep in mind. When you build a network, you really want to look ahead, think a few moves ahead of what you're currently doing, so that you don't run into space issues with towns being in very, very annoying places, or radio towers for that matter. So that's a thing to keep in mind. Now this is a quite advanced network, but you don't start out like this. So let's take a look at what a startup network really looks like. So this could be your very first main track line. Now, as you can see, we just got two, tracks of, well, maglev track in this case, but tracks of railroad, and each track has its own direction really. I've set it up in the European style. You could also go English style with this, but I prefer our trains driving on the right side. Not that they have a choice, but anyway, so this could be your first main track line. Now, the thing you want to keep in mind when building your first main track line is that you want to choose a location which doesn't have massive height elevations in there. Of course, when you start out, you don't have a lot of cash, so a few slopes are inevitable maybe. But generally speaking, when you're a bit later in the game and you plan new main track lines, you want to keep the amount of slopes in there to a minimum, preferably 0. So, with that said, if we just move along this main track line, you can see that we got like the most basic form of a junction over here. And this is really just a one-way junction. It's actually more of a kind of like curve going beneath here. Traffic can only come from this direction and only go into this direction with this junction. What it leads to is just a supply line to a forest really. Now, I just said about slopes not being good in the main track line. Of course, you can't just have everything be on the same level, and slopes in your supplying tracks, your branches that go off the main track line, they aren't as bad. There are a few things to keep in mind though. As you can see over here, it is set up quite spacious, and that's the thing you generally speaking want to do, because what you have over here really is a slope which slows trains down, but then there's a substantial track length going on that same level where the trains can accelerate again, so they don't merge onto the main track line with a really low speed. Now over here on the other side, the same thing doesn't apply, because instead of having to climb up a slope, here the trains drop down a high level, and of course they accelerate rather than slow down from that. So here it's less of an issue, but in terms of slopes, and you generally want to place them very carefully because of the acceleration the trains need to do afterwards. Now this is the most basic form of a junction. Let's take a look at some more advanced junctions. So over here we got a more advanced junction. In fact, this is a fully fledged junction for some very simple main track lines. So you can see the main track lines are still 2-lane, And the first thing you'll notice is the height difference over here. Like I mentioned, this is good practice so that you don't have any slopes in the main track line going in the main direction. Now, what happens over here, when you just look at it, it might be a little bit of a mess, but let me just color this in for you so you got an idea of where each track leads to. So these are the main track lines, and then these are like the exits going on from that main track line to the other. Now, as you can see, there is actually some sense in this junction. And let me just explain a few things that are important when building a junction like this. For one, with these slopes and the declines I just mentioned, to keep it a bit, clear and have an idea of what you're doing, I tend to build slopes and declines at the place where the track starts to run parallel with the main track line that it's trying to merge onto. An example of this is over here. Say a train goes over here, follows this track along the mouse cursor. Then at this point, the track starts to run into parallel with this main track line, and thus it drops a height level. The same is also true for, say for example, train follows my mouse cursor over here. At this point the track runs in parallel with this main track line, and there is a slope. This is just to keep it nice and tidy. Of course, you don't really need to do it like this. You could also put the slope a bit earlier or later on. However, I find this method, with this method I find it quite easy to make these junctions. Now, in terms of slope placement, you can see that each slope has a quite substantial track length in front of it, so that a train climbing this slope wouldn't be blocking off this junction here with the back end. If it's climbing this slope, then the back end would probably be over here. That is assuming that you run with a maximum train length of 7. If you have longer trains, then your junction will need to be bigger in order for these trains not to block the junction over here with the back end. So you need to keep that in mind when you set up your maximum train length. You really, the longer your trains are, the bigger your junctions will be, even these simple ones. Now then, how does a junction like this gets built up? Let's just take you through it, step by step. So here we got a main track line and a supply line. Currently there is no junction, and the most simple junction looks really easy. And it would look like this. This is a one-way junction really, where traffic can only go into these directions. Now at some point you might hook up more resource nodes to this supply line, and you've got traffic also needing to go to the other direction. And this is what the junction would look like. This is effectively just a fully fledged T-junction. Now there are a few things you might notice straight away. For one, I did change this slope a little bit so that there is at least enough track length that a train wouldn't block off this junction over here if it's climbing the slope. That's really important. Over here it doesn't matter so much because there are no junctions, so that's another thing. You'll notice as well that there's quite a bit of track length over here on the same height level as the main track line, and that is for the trains to speed up. And the same is true over here as well as over here. That way at least the trains do have some speed. Now this is just a simple T-junction. At some point this supply line might actually become like a main track line with trains also needing to go into this direction, and then it starts to become more complicated, because at the moment really these are just two mirrored one-way junctions, and the moment you have to you're gonna have a track going straight over here, then things become more advanced, as you'll see. And this is what the junction would look like And this is really nothing more than the same T-junction, but it also has the option to go straight into that direction. But you can already see that a few things have changed. For one, that I put a bridge over here because in general I like to have bridges above the main track line rather than have the main track line go through tunnels, just to keep it more visible. You'll also notice that I actually extended this track to be more on this height level, so it could cross these new tracks going straight. You'll also notice that instead of having this join up over here, which is where it was initially, I have hooked it up to this exit. That is to just keep the amount of tracks going, merging on the main track line to a minimum, and I should have done that over here as well with this track. Now when you hook this one up over here, it doesn't really matter much where this slope is, as the trains have to drop down from this direction. Over here though, you do want to adjust where this slope is, because if a train has to climb this slope at the moment, its back end would be well over this junction. So what you generally want to do is put that slope a bit more backwards, like this. And now you have a lot more space and the train wouldn't be blocking off this junction. So, at some point you might want to upgrade this to have it to have trains also be able to go into this direction from over here. And this is what it looks like when it's more advanced. Right now really there's only one direction missing, but already you can see that it really starts to look like the junction we looked at before we started building this. I did set this up to be quite spacious, but as you can see now, by adding like the more final pieces, that space is actually quite needed, because if this were to be a lot more smaller, then we would have to use the girder bridges, which I'll show you, which would be these kind of, and as you can see they are really slow. Now of course it doesn't matter when you just start out, but later on you generally want to avoid these bridges because they are so slow. Also you can see that over here there's actually quite a long set of straight before the drop down, and that is just to keep some space for the latest addition that you would have to make if you want to make this a fully fledged all directional junction. Now if we were to do that, we would end up with the same junction we just looked at, only a little bit bigger. I'm not gonna do that, but this is how I generally build junctions, and these are just the most common type of junctions. Now there are another type of junctions which don't follow these building methods, and that is when say for example you got a lot of traffic and that all needs to make this curve. In that case you don't really want to have the slopes and stuff be in that curve. For example, if you got like 75% of the traffic on this junction all needs to go over there, it's actually preferable to keep the whole junction on the same level as well as the main track line. I don't plan these junctions out in particular. It generally happens when you got a curve in your main track line and then you have to have like some kind of entrance and exits from that, and you're in need of a junction. I have an example for that in my network and I'll show you that now. Over here really we have this junction. What you see over here is that the main direction of traffic is in this general direction. However, there's also a supply line over here that has to go into like both this and that direction. Now because the majority of the traffic goes over here, I chose to keep these track lines on the same height level and have the tracks going straight actually make a decline and slope and that stuff in them. So immediately you can see as well that a junction looks radically different than the things we've just built. There's a lot of bridges and slopes in them, and yeah, well, you know, it was a bit of bad planning on my part, but sometimes the situation might arise that you need a junction like this. Now, like I said, it's really important that you keep the main flow of traffic slope free, and as well as you know, you keep the amount of merging onto those tracks to a minimum. So you want to do quite some merging before that. And what you see over here as well is that the trains from this direction can merge onto all 3 tracks, you know, to all 3 directions really, because they come into the switch over here on both the inner lane and the outer or the center lane. So that's the way this is set up currently. Now, we've just taken quite an extensive look at junctions, but your network over time also will grow. You will start to expand, you'll get more trains and a lot more traffic, and at some point your 2-lane track lines aren't sufficient anymore and you start to get traffic jams. Now, you can, well, if you play with breakdowns it might be a bit harder, but if you don't play with breakdowns it's quite easy to see when you got your main track line saturated. And that is when you start to see traffic jams at like the beginning of a junction or at a station. If you see that, you know that it's time to start upgrading your main track line from 2 to 4 lane, and that's when things get really complicated. And with complicated, I mean really complicated. This over here is a junction that is in a 4-lane main track situation. Now this might look really complicated to you at first, but it's actually not all that complicated if we dissect it a little bit. Because really what it is it's the same, you know, 2-lane omnidirectional junction, to put it like that. And then I just added another junction around that first junction. So to make a bit more clear, these tracks are all tracks related to the inner junction, the 2-lane one. And then these tracks are the ones that I added because we had a 4-lane situation at the moment. And that way it looks all of a sudden it looks a lot less complicated. Now if we take a more in-depth look at some specific stuff over here, you can see that a lot of these slopes have a good stretch of, well, straight track on the same level in front of them, like over here for example. You know, there's a lot of track leading up to the slope, and there's more of that as well as over here. And that's just why you want to keep you know, quite a bit of space around these junctions, so that you have the possibility to add these tracks in front of slopes. Now if we zoom out again, you might wonder like what all these tracks do really, and if we just cancel out these inner junction tracks, these are like the directions for the outer track lines and their junction exits. And all of a sudden you can see that it isn't as complicated as it might seem, though if we remove these colors, the picture on the whole might look complicated again. Now an important thing to note is that in this junction the trains don't have the possibility to merge from the outer lane towards the inner track lane. They can go, however, to another outer lane, but they can't make that merge. Now that is done on purpose. Generally speaking, you don't want to have these you know, these switches from the inner to the outer lane or vice versa in your junction. You want to have switches in front of your junction so that trains can make that switch before entering it. If you have switches in there as well, it just adds a lot more merging and into the junction, and that way you have more traffic jams inside, jamming the whole thing. So that's a thing you really want to keep in mind. Another thing about this junction as well is that, as you can see, it's quite big. Usually when you have a 4-lane junction, you do want to prepare quite carefully for that. For the rest though, and there's not much more to it than the 2-lane simple junction. There is, however, it's not completely equal, because one thing that I have set up is that if a train is on the outer lane over here and then it wants to go straight, just continue on to this direction, it has two options. A train could continue on going straight and then follow my mouse cursor over there. It could, however, also climb this slope and then go straight. Now the reason at first I had set it up like a train could go straight only by taking this exit, but I also set it up that a train could go straight over here, so that they don't necessarily have to climb slopes in order to go straight. However, I also added the option because there might be a traffic jam for some reason over here, and then they at least have an alternative route to go straight, because it is still the main track line even though it's on the outer side. It is the most important direction, so I wanted to keep sure that at least the main direction of traffic would be able to continue on going through the junction even if some parts of it were jammed. And that's pretty much it for this junction. Now let's take a more in-depth look at it and how you set this up. So as you can see, we have the same basic 2-lane junction over here already, but now I have added the 4-lane tracks. So let's just say that we are gonna have to have a simple T-junction along with this, from this direction to over here and over here. I'm gonna ignore the fact that there are also these 4-lane tracks over here for now, and I'm just going to show you like how you set that up. So this is what it would look like halfway. You'd have the same junction over here, and then all we have now is just the most simple form of the junction I explained like at the start of this tutorial, only then much bigger because it is for the outer lanes and it has to go around this junction completely. Also, you might notice an odd thing with the slopes and the fact that it just happens over here in the middle of a track running in parallel. Those that rule of thumb that I explained there really applies to these simple 2-lane junctions, but you do wanna loosen that a bit when you are building the bigger junctions, and just generally plan ahead carefully and not have slopes right in front of junctions. That's just when you're building these more advanced things. So if you then were to make a T-junction out of this, you would then end up with something like this. This is a T-junction. Now already you can see that it starts to become really complicated, and these are the tracks I just newly added. I also did add a bridge over here, because if I didn't, I'd have to have this line of track go straight, make a tight curve here, and then hook up over there. So a bridge is preferable. Now you can see as well that these two tracks are new. I made those for the outer junction, and you can see that I kept a 3-space a 3-tile space between those tracks for any future building that I might have to do over there. For the rest, you can also see that there's quite a lot of space over here, but that is only to keep it a bit spacious, and that's generally preferable. So if you then later on have to add like another track somewhere, you have the space to just edit it in, rather than having to rework the whole junction. Now if you were to make this a complete, fully fledged 4-lane junction, being able to go into all directions, it would look something like this. And now it resembles the junction we just looked at before we started building this one pretty well. Now already it is a big mass of tracks now, an organized mass, but let me just color in the new tracks added. And as you can see here as well, I did start this out a little bit too cramped, so I had to relocate these tracks over here so that there was a little bit more space available. Now, in terms of where each track goes, there is like one big flaw yet over here, and that is that if a train comes in on the outer lane, it always has to go to a direction. And that's like not really necessarily a good thing, so it would be quite easy to have the outer tracks also be going straight, and that would be to add track pieces on these places. I haven't done that for now, but if I did, it would have been exactly the same junction as the one we just looked at. Now this is really a big junction, and those you don't build those at the start of your network, but later on you do find yourself building these kind of junctions quite often, or parts of it. Another thing that you want to keep in mind is that this is really, in terms of how complicated junctions can become, at their base this is the most complicated structure. If you have, like, for example, 6-lane supply tracks, which could very well happen, you don't want to build this even bigger, because if we zoom out you can see that it is already really big. If you want a if you have 6-lane supply tracks, generally what you want to do is you want to have the inner lane tracks just keep on going straight and not have any merging or junctioning tracks onto them. So you'll just have like right now we have 2 set of tracks going straight over here, 2 track lines. Then you'll have 4 with the same junction going about it. Of course it's up to you, but generally it's preferable. Also in terms of load distribution, and that's a thing we'll touch on a little bit later. For now this is the junction, a fully fledged 4-lane junction. Good. With the junctions now covered more or less, let's take a look at the network and see how these junctions are put in there. So here we have a 6-lane junction really, and it is a bit different from the thing I've just shown you, and that's basically because it just takes up a little bit more space so that I could add additional tracks if needed regarding load distribution. However, at the base of it, it is the same kind of junction. You have the supply tracks here, but you'll notice that the inner supply lanes go straight. However, the center supply lanes also make like a curve in it. However, they still trains can still continue on along them, just move in a straight line. They don't have to interfere with the junction, but I did set it up like that to have more space available. So let's just color in a few directions so you get a bit more sense of like where the tracks lead up to. Now, as you can see, this junction is quite heavy, but also a few interesting things happen over here. Whereas in the previous example, I just showed you a junction where you had an equal amount of supply lanes coming in from all directions. Over here you can see that there's actually a merge and a split happening in this direction, because over here we have 4-lane, but over here we have 2-lane. Now, generally speaking, you want to have this merging happen as close to the main supply track as possible, and not in the junction itself, because that could cause heavy traffic jams. And in fact, you can see it over here. There is a small traffic jam on this outer lane because a lot of merging is happening for this 2-lane supply track. You could argue that I should have upgraded it to 4-lane, but This is a tutorial, and I haven't, so. But yeah, this is one of those junctions put in practice over here. This started out really as a T-junction leading up to over here to this power station, but later on I added another station over here, and I had to make this a complete junction. Take notice as well that it takes a lot of space, but this one is working quite efficiently. If you see it into action, as you can see, there's a lot of traffic going over here, and here's what I mean with having enough space in front of a slope. You saw that train climbing the slope over here. If another train would be able, would want to go over here, it would be able to. So that's why it's really important to keep enough space in front of slopes. Also, you'll notice that there aren't a lot of merging tracks over here, because I followed the same principle that I did with the junctions I just shown you. And there's only like more or less 2 merging tracks onto each main track line. So that's this junction. Now this is a fully fledged junction, but there are more simpler versions of this. So let's take a look at a more simplified version. So over here we have a T-junction, and it's a bit more simplified, but it does have one odd thing going for it, and that is that because of the load balancing, instead of having it hook up to the outer lanes, because this is a 6-lane supply track, instead of having it hook up to the outer lanes, I had it hook up to the inner lanes actually, to distribute the traffic a bit better among the network. You can see that over here it only has 4 supply lanes, so one lane really does not have a merging from this junction. But for the rest, you can see that it's a really simple T-junction. You can see here where basically what you have is like you got 2 one-way junctions over here, and then 2 going to this direction, and that's it. Now there are a lot more junctions in this network. The thing is, the things I've just shown you is in ideal situations. A few things you need to keep in mind in building junctions is that you need to adapt to what your network needs and to the area around you. If you got a massive mountain like right close to your network, you might want to build a junction like a few miles. I don't really know what the distances are in this game. You want to move your junction up a little bit so you can avoid that mountain. Same goes for towns and stuff. Or maybe like I did over here, you got some traffic distribution to do, and you might want to hook it up differently. So I mean, I could just give you tips and ideas till forever like how you should build a junction, but the strength of a well-built junction is that it's tailor-made to the situation that it needs to handle. So that's more or less everything that I know about junctions. But there's also network management, and in particular load distribution. Now this only applies to when your network has grown really big and you got more than just 2-lane main track lines. If you're just starting out, this isn't, this doesn't apply to you. But really, when you start upgrading to 4-lane or more, you need to take a look at how you distribute the trains among those multiple supply lanes on your main track. Now, the way to do that is to build switches, and let's take a look at some switch designs. So over here I've built 2 switches. There's one really simple switch, that's this one. It takes up no extra space, but I personally don't use it. There are a few disadvantages to it. For one, if a train needs to switch to the outer lane, for example, it will block off all the traffic coming from this direction because it's making the switch. Another thing as well is that because it's so small, the train has to make 2 curves in real short succession, and therefore it slows down quite a bit. So not only is it blocking the traffic, but it's also doing that longer than is necessary. So that's why I use these switches over here. They are a bit bigger, but the advantage of this is that if a train needs to make a switch, then it can be, you know, like on this inner track, and it doesn't block off traffic for both directions. It will only block traffic at best, you know, or at a worst situation for one lane. And that's the real advantage of it. Now, you might be wondering about the signaling over here, so let's take a quick look at how this is signaled and how it's set up. This is quite easy. These are just pathing signals, and they'll deal with all the traffic on their own. But over here we got pre-pathing signals, so let's take a look. We got our entrance signals over here, and then we got quite a few exit signals over here, and only 3 combo signals. Now the way this works really is that this switch track, so to say, the one that trains use to switch, once a train is on there, any other train should not be able to go on it, and that's why we got 3 combi signals over here. Because the moment a train enters from over here, then everything will turn red, and the same is really true for a train. You know, if these 2 exit tracks are like filled up, you know, there's like trains passing both over here, and there's no point in switching really, because both these tracks are occupied, and that's why we got a combi signal over here as well, so that trains will just keep on going straight, because that is the best way for them to go. Now, one disadvantage to this switch is that not only does it take up more space, but if you got your trains, you know, really close behind each other, say for example there's only like a 3 tile gap between your trains, then when they enter this switch, you know what, the first train will go straight, the second train will go over here, only to merge back here after that train, and that is because there are signals missing over here. Now, you generally don't want to place signals over here, because and I'll touch, we'll go a bit more in detail about that in a moment, but these switches generally are meant to distribute traffic. Now, if traffic, if you don't have a lot of traffic going on, you don't need to distribute traffic, but these switches are generally meant to distribute traffic because at the moment it is unevenly balanced, or you got slopes or stuff. So you don't want us to have signals over here, because if there is a traffic jam, for example, and a train wouldn't be able to continue onto this path, it would however go over here and then have a red signal, stop, and then block off all traffic. So that's why you don't want any signals in between, even though it's quite a long stretch without signals. And you might notice as well that we got like these 2 exit signals here right next to each other. They'll just behave as regular signals, so a train can come over here and then find that there's a train making a switch, wait, and then another train will be able to pass along over here. So these straight tracks also act as some kind of buffer. So that's why you see quite a few exit signals over here. If these were to be all combi signals, then instead of having the buffer here on the tracks, the trains would wait in front of the switch, which is not really what I wanted. So now that you know how this switch works, let's see it into action. So here we got that same switch, but now in maglev tracks, and let's see it into action. And of course you'll see that, alright. So here a train comes, but it needs to wait for a train to climb this slope. This train noticed that, and it immediately chooses the other track, because over here the train was still climbing the slope. Now this is where the switches come in at their best, and that is in front of slopes, because the trains slow down quite a bit. Right now they can use the other track to also slow down, and by choosing the other track, this one is already almost freed up, and so any next trains that come can choose just the straight line again, like this one will do right now. So also, as you can see, generally speaking, in a network, the inner lane is most of the times more preferred to the outer lane. So if a train comes into a switch and there is no traffic at all, it's just that one train, what it will do is it will try to switch to the inner lane because, well, like I said, it's generally speaking faster because, as you saw with those junctions, the outer lanes had a lot more track going around, you know, making bends and stuff than the inner section of that junction. So don't be surprised if you put a switch at the wrong spot where there's not a lot of traffic, that all of a sudden you'll have all your traffic on the inner lane. Now this is a switch that you can only use really for 2-lane tracks. And this is, you know, well, for trains to be able to go to switch from both tracks to both tracks. You could also set this up as a one-way switch, and then you just have to remove like either this piece and this piece, or this piece and that piece. One-way switches sometimes are preferred if you have a particular traffic situation where the load distribution is suboptimal, but there's still a lot of directions going on, and we'll touch on that in a moment. Now you can also have 3 lanes, you know, supply direction, like a 6-lane main track. At that moment, you know, at that point, you'll have need for like more advanced switches. Now you could just extend that really simple switch design with the pathing signals that I just showed you, but the disadvantages of that would only become more apparent. So here is the design that I used for 3 lanes, and that's this one. Now this looks a lot more complicated, but let me just clear off a few trees like this. But in reality it isn't all that complicated. Now you do see quite a lot of signals over here, but in essence, if you take a look, each train is able to switch to each other lane, and I think it's best to just explain this while it's working. So in here you have 3 slopes leading up to the roundabout station. Now what you see over here really is that trains will be able to choose whichever track is free and then just use the switch accordingly. However, there are a few moments in this switch where they can decide to change route, and that's really, if you take a more zoomed in look, you can see that the entrance signals are over here and the combi signals are over there, and at each combo signal the train can really choose you know, a new route to reach its destination, which in this case is just any of the 3 tracks. Any exit will do. Now you also see that we got a combo signal over here, and that is just because I didn't want there to be like a big buffer over here, since we got quite a bit of buffer on these tracks. So that's why we have a combo signal over here. You could as well use an exit signal over here, and that would work too, but you then have this track act as a buffer, which I didn't want over here in this switch. For the rest, this switch, it does take up quite a lot more space, and you want to use it really sparingly, because this switch it really does make the trains slow down. So the best use of these switches is in front of stations or at the exit of a station, as you can see over here. Now in front of a station, it's really just to distribute the load of trains evenly among the stations, as you can see over here. At the exit of the station, it's not really there to distribute the load evenly, but it is to give the trains the option to choose the right track for them to reach their returning destination. Most of the times, a lot of the exits on a network are on like the outer or the center track, but not on the inner lane, if we're talking about a 6-lane main track. So a lot of trains need to make a switch to either the outer or the center lane. However, there might also be long distance trains that are perfectly fine with the inner lane. So you do want one of those switches at the exit of a track. Otherwise, you might see a lot of trains looping at a station where they're not supposed to go just to reach that outer track. Now these are switches, but the key to a good switch is not that it's perfectly signaled and well set up. The key to a good switch is the placement. So let's take a more in-depth look at that. So here we are back to that example of that 2-lane switch I just used. And one really good use for switches is to put them in front of slopes, so that you won't have massive traffic jams on one track while the other one is empty. Now, switches are there to distribute traffic loads. If you have a network where all the traffic comes, is distributed evenly, you don't need to build switches. But you do want to build switches if you notice that one track is virtually unused while the other one gets heavy traffic. However, you don't want to place them just at any point in your network. Like I said, you want to place them in front of slopes if you happen to have them in your main track line. Most of the times you'll have slopes in like your junctions, and if you got a really big junction with a lot of space, you might want to consider putting a switch in front of that slope. Another good place for switches is in front of a junction. So let's take a look at that. So here we have a basic T junction, and as you can see, both entrance tracks have a switch in front of them. That is just for the trains to be able to choose the, if they need to be on this T junction, they can then use the switch to the outer lane and hop onto this T junction, while they won't have to make, to use the outer track already coming all the way up to this T junction. They could also use the inner lane, so the traffic gets distributed more evenly on the tracks leading up to the T junction, and the same is true for the other side. Now, you might also notice that I haven't put any switches in the exit tracks of this junction, but that is really because, as you can see, this is a 2-lane track while this is a 4-lane track, so there is really no need for switches, as I had that just hook up to the outer lane only, which is where most of the exits from the main track are anyway. So another place where you want to consider switches as well is in front of really busy branches that branch off your main track. And that is what we have over here, for example. If we take a more zoomed out look and look at this particular situation in the network, this is a really simple one-way junction. However, it does lead up to 3 iron ore mines, and they are both very, very productive. 500 tons, it's a bit hard to click, wait, 900 tons and 500 tons. So that's a lot of production and a lot of traffic. That's why I put the switch in front of this junction over here, so that trains would be able to use the center tracks as well as the outer tracks, rather than just be forced to go on the outer tracks alone, which also has other tracks joining and splitting up from that as well. That way you get a little bit more even load distribution. The same is true as well over here for this junction. Now, another thing you can consider doing, and well, I've done it over here, is that when you got like a really a branch off that sees heavy traffic, you could also place a switch in front of the merging of those tracks coming off that branch, so that because a lot of trains will be merging onto the outer track over here, you could easily get traffic jams if there are too many trains merging on. You then want to have a switch in front of it, so the trains on the outer track already can switch to the center track, whilst the trains over here are merging onto the main track line. So that's another place where you might want to consider a switch if you notice you have traffic jams on certain junctions from your branches on your main track. Another place where you might want to consider switches is if you have one traffic jam that's really long and you want to like cut it in half because you have too many trains going to a station. And I'll show you an example of that. As you can see over here, we got a switch just in the middle of a set of tracks. There's no junction for it at all, and currently I could remove this as well, as it doesn't serve any purpose anymore. But if you followed the Let's Play series, you'll know why it's there, and that's because I had a traffic jam leading all the way up till here, till this junction from the station. It was one big traffic jam, and the way I cut that traffic jam in half and freed up this junction again was by making a switch over here, so that instead of just the traffic jam being on the outer lane only, now it would also use the center lane, which was virtually unused at that time. So that's another use for switches. Generally speaking though, switches really are, well, you know, you want switches to provide options for your trains. So if you only build them in front of junctions or only build them you know, at stations, then the trains still won't have a lot of options. You do need to build them there, of course, but you really also want some switches in front of like really busy support branches or slopes to distribute the traffic more evenly. And that's pretty much it about the switches. Now, another few, I just want to touch upon a few things that are network related, but not really to switches or junctions in general. When you're upgrading to 6 lane, generally I tend to keep the inner lane, you know, like these 2 center ones, to not have any branches going to and from them, but generally they just serve as junction to junction transportation, so that you know, there's really that inner lane is really only used by the long distance trains, so to say. You can see that over here quite well, where we got this inner lane over here that leads from this steel station, and it goes all the way up till here to this factory. And well, the first switch encounters is over here at this junction. So all those trains that are in the inner lane can only go straight all the way up till here, only then can they make a switch. So that's a thing you want to, you know, what I consider good practice for once you're upgrading to the bigger number of lanes. Now, another thing you might wonder, like, okay, so you got 6 lane over here, but what if you go up to 8 or 10 or even 12 lane? Well, in terms of switches, really you don't want to just, you know, make even bigger switches than these. These are really for 3 lane examples. What you want to do when you go up even in the higher numbers is just make a combination of like a 2 lane switch and then a 3 lane switch afterwards, or maybe just divide the traffic some more, so you have like just 2 3 lane switches right next to each other, or maybe one in the center. But you don't want to have switches that make the trains able to just switch between all 8 lanes, for example. Because what would happens if a train has to go from the outer lane to the inner lane because it thinks it's faster? It's essentially blocking off all the traffic. So you do want to be careful with that. Another thing that I wanted to show you is over here. Here you see how I have like a 2 lane switch with a 1 way 3rd lane switch added to it. And that is because you know, as I said, you need to provide your trains with options. Now it could very well happen that the trains want to go to, you know, they need to go beyond this junction. So they all would want to go to the inner lane of the tracks going in this direction. Now if you take a look at the station over here, what would happen is that most of the trains would try to go to that inner lane in this switch already, and that would cause for quite a few traffic jams right at the exit tracks of this station. So instead of having the trains trying to switch to the inner lane over here everywhere, I provided them with an option of switching to the inner lane over here, because right now it doesn't make a lot of difference in terms of track length whether or not they choose the inner or the center or the outer lane. So, but I didn't want, you know, trains who do not have to go beyond this junction use the inner lane as well, because of course they do think that it's faster. So that's why it's only a 1-way switch over here. Another place where you don't want to put switches is in your junction. You want to have it in front or afterwards, but not really inside your junction, as that might very well cause traffic jams, and you don't want those in your junction. For the rest, well, I can't really think of much more to add to network management. Well, there is of course, you know, just a few general tips and tricks. Like I said, you know, at some point, you know, you'll start growing and you'll find that these resource nodes start to go hyperactive, like this one, where you got 2.3 thousand tons of iron ore each month. Now this is gonna cause a lot of traffic, and if you got like 5 of these iron ore mines, really soon you'll find that you are saturating a very big station. Now you could keep expanding a station, but at some point you really can't expand it anymore, and you might have traffic jams already. What you can do then is just hook up another station and reroute those trains, like I did over here with another steel mill station. Another thing that is, well, you know, for a network that is good practice, and I haven't done that over here, but is to not build your big stations right in, you know, at the center of a main traffic line, like I have done over here with the roundabout station. Really, if you wanna, you know, keep transporting everything to everywhere, right now currently, because this roundabout station is over here, if I had iron ore mines over here that needed to go past this roundabout, they would have to go through here. Now a bypass track would be enormous because, well, it'd have to go all around this roundabout station, which is already very big. So generally speaking, you actually want to have your main tracks, for example, extend over here and then hook up, you know, and have just a junction leading to the big stations. But, well, you know, I'm not perfect either, so I haven't done it over here. And that's pretty much it. Now, if you have any more questions, you know, regarding all these tutorials about God knows what, feel free to ask, but that's pretty much, well, you know, more or less what I know about this game and the methods that I use to play this and to set up this big network and make it as big as it is today. So I hope you enjoyed it, I hope you learned something from it, and have fun playing the game yourself.